Hey everyone. So it's been a hot minute. Actually, I guess I streamed on Halloween. So it's been a minute, maybe not a hot minute, but it's been a minute. Oh, that's why. That's the okay. I'm looking at the wrong Twitch link. That makes more sense. Okay, cool. Doo, 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 doo. So, yeah. Doo, doo, doo. Join me. So today, this morning, we're going to try and revive some old PRs that I kind of let die or like fall off. And we're going to try and bring them back. Spooky adjacent after Halloween time, but I think we can extend it out a little bit. In interest of the war on Christmas. For some not so spooky. Zombie PR adventures. Bringing back. Fail. Dead PRs. And Apache Spark. Yeah. Okay. Cool. Let's make sure that it did actually go to the YouTube as well. Channel. Great success. Great success. Okay, cool. Okay. Anyways, it's going to be immensely fun. For immensely fun values, which are pretty fun adjacent. Yeah. And then we're gonna go to discuss. Go to great success. Oh god damn it. Why is there a meme coin of the cat that got hit by a Waymo? I hate our future. Okay, well, great success. So let's begin bringing our zombie PR back to life. Ooh, magic! Okay, so the first step is we want to go ahead and remove the stale label, because if we don't do that, GitHub will just come along and bonk it back on top of the head again and make it fall over. So go down here. I've got some time to work on this again. Let's see. Cool, fantastic, great success. So let's bring it back. Ah, la. Oh, okay. So we brought it back from the dead, but we brought it back from the dead, and it turns out that it's got some conflicts, which is not surprising, right? Like the act of bringing code back from the dead is a little, yeah. Yeah. Okay. Correct. Oh, the other thing I need to do. Well, should I do it now? I should do it now. Well, we'll do it now. Yeehaw. I'll make a LinkedIn post later. But those of you who joined the stream early, get the inside scoop, I would say. So great success there. Okay. So right. Oh yeah, get remote, get Apache master. Okay. Over here. check this out. And then my branch is behind origin by 3 commits. Okay, interesting. Okay, okay. I guess I did some work on the integration test suite, but like I didn't do it on this computer, which is fine. Okay. Let's take a look. So okay. Cool. Block manager master endpoint. Block manager master endpoint Scala inside of storage. Okay. Let's go yes. Fine. Okay. So thing that we want to bring over is probably this. Update block access time. So we don't change the indent on that. Okay, and then this is internal config package.scala. Yeah, that's the one I want. Fine. Okay. We keep all of these, and then yeah, let's just 2 new ones go here. This is fine. Okay, fantastic. Okay, great. Okay. Yeah. Let's take a hot minute. Yeah, I guess I did most of my work previously on my laptop, and so the state on my desktop is a little out of sync. But we will resurrect this PR from the dead. It'll be fantastic. It'll be fantastic. And maybe this afternoon I'll do a code review time. We'll see. We'll see. Okay. While that's running, let's go back and take a look at our previous, sort of the previous state of this, because like where this left off was like in March, and I don't know about you, but like I have difficulty remembering yesterday, let alone today. So let's go take a look at our previous test failure. Okay, well, the logs are gone, which makes sense for a zombie, but that's okay. Interestingly, the only thing that failed was streaming SQL Kafka. Huh. It's like not the test I would have expected to fail. So let's go over here. Let's take a look at the code and just try and like sort of refresh our memory. Okay, yeah. So this is intentional. We accept that access times that are close, whatever, it's okay. So we intentionally don't care about concurrency here, and we're okay with like volatile over, like we're okay with having slightly incorrect ones to be able to update this in a lower cost way. That makes sense. That's configurable. That also makes sense. Update shuffle A time. Okay. So if it's enabled, do the thing. Otherwise, we just don't do anything. That's fine. And then this is our little TTL cleaner suite. And then yeah, nothing scarier than zombie blocks. Good point. Oh, Giorgio, I haven't. I miss our chats. We should catch up. We should catch up. But yeah, anyways, so a bit of the reasoning for this is like notebooks can hang on to blocks for like a very long time, sort of by accident, and this can make issues for scale down. And so this is the kind of thing which can make scale down better. And so like we'll try and make this better. Okay, this looks like a change in shuffle rdd.scala is almost certainly not needed. Let's see if that's still in the repo. Okay. Oh, yeehaw. My bad. Okay, let's go take a look at that. Git diff master shuffled RDD. Yeah, okay, so we've got a change that we just need to back out because there's no need for a change to shuffled RDD.scala. Shuffled RDD.scala, and it's doesn't tell me what line, but get dependencies. Yeah. Okay, cool. Fantastic. Oh. Okay. Okay. Back out unneeded change. Shuffled RDD Scala. Cool. Okay. Let's keep going. Let's keep going. Okay, yeah, cool. And so this says like, hey, what's up? So on this, essentially what we do, this is extends the block ID and it lets us get a shuffle ID off of a block ID if it is a shuffle block, otherwise we just get none. And then we get this nice little trait here. It's a developer trait, and so it's fine. We shouldn't get yelled at for changing that too much. And yeah, here, because we do have different kinds of shuffle blocks, we want all of them to have this with shuffle ID so we can get the shuffle ID off of them. That seems fine. Block manager master endpoints. I should probably make the same comment here as we had in the other one as to like why we're not actually using a concurrent data structure, because it's a very natural thing to be like, yo, use a concurrent data structure, but we don't actually need one here because we don't care about like things that are pretty close, right? As the saying goes, close only counts in horseshoes and hand grenades, but I would say close also counts in access times. You know, a few hundred milliseconds one way or the other shouldn't matter, and if it does, you're probably using this feature in a way that's not what I wanted. Block manager master endpoint. That's gone. Fantastic, and this is going to be line 88. Give or take now. If we're using block TTLs, we intentionally use non-concurrent data structure since close is good enough for A times. and reducing update cost matters. Fantastic. Cool. This seems fine. Yeah, okay. Other notes to myself. I appreciate myself for writing these notes to myself because, yeah, I don't always remember what the hell. But like, yeah, it's like this is a place where we're doing a thing with the block intentionally. We don't need to update the access time because this isn't a real thing. Okay, cool. Yeah. Similarly, okay, we could use. Oh yeah, okay. I was thinking we could use a parallel map, but like, no, this is actually, we're just doing a map because it's giving us back an option, so we don't need anything fancy. No fancy footwork required. There. Let's keep going. Let's keep going. Yeah. Okay. And then we've got our integration suite, which it has fairly aggressive patience intervals. We might have to back those off for like CI purposes, because like CI might not run as nicely. But okay, cool. This doesn't look bad. Like first thoughts. Cool. Compiles. Which I think we're good to push it. Force with release. Fantastic. And then what are we going to do here? So I am curious, who implemented the original TTL cleaner functionality in Spark Core? Because let's go find them. Yes, not me. I want to know who added the TTL before me. Or maybe I wrote this down in the JIRA. That might be the case, and then I can, because essentially now the thing is we want to find someone to review this code that we have brought back from the dead. Sorry. It's important to have drawing your work, because like, yeah. Here's the issue. Yeah, okay. So this removed the original TTL cleaner code. Well, but that's Josh, you know? I don't know, this is another zombie PR that I'm looking at maybe bringing back later on. Is there's an issue essentially with filter pushdown in Spark where we can have double filter evaluation unnecessarily, which is fine for inexpensive filters, but for UDFs it's pretty terrible. Or for filters with UDFs it can be pretty bad. Let's go ahead. CC at Josh. Rosin. Using. Yeah. What are your thoughts? Do you have some cycles to review? Yeah. Other thing that I want to do over here. is minus. I have an 11 o'clock. I feel like I might have an 11 o'clock that I need to go to. Let's double check. Oh, no, it's an 11:30. Fantastic. Great notes. Great. No notes. Okay. Yeah. Yeah. I'm gonna add a comment here. Oh, I'm not signed in. Okay. Is that gonna work? Probably not. Yeah. Okay. It's gonna be. I've got. It's gonna be this one. I think is the one that's for the. Okay. Yeah. Okay. And then what are we gonna do here? This one. Oh yeah. Okay. A possible middle ground. Okay, a possible future middle ground could be migrate all blocks to non-attached storage. Blob storage. After some TTL has expired. After some... There we go. And so this is just like, hey, there's another thing that we could do here too. That might be better. It might not, though, but I want to write it down so I don't forget about it. Oh, okay. Oh. Let's see here. And what's the comment? I'm not sure. I was wondering what would trigger the start of the TTL timer. Is it when we know about a map output, when the map stage finishes, when... Yeah. So the TTL timer is based on the last access time, which includes the initial write time. Cool. There we go. Great success. Great success. Okay, cool. Honestly, that took less time than I thought it was going to take. That's pretty fantastic. Do we want to... go and explore the other possible zombie PR? This one is less zombie. Like this one is very zombie because it's about like zombie blocks. So blocks that essentially like are just hanging out dead and unused. But we'll bring them back. Ooh, this sounds interesting. Maybe code review. Yeah, okay, we'll definitely do a code review stream tonight. Okay, this merges cleanly, but like it needs some love. Most likely. Okay. I like this one personally. It's relatively simple. Let's talk through the second zombie PR before I have to run. So the second zombie PR that I'm thinking about bringing back from the dead is avoiding double eval from filter pushdown with projection pushdown. And this is the thing where if you've got a UDF and you're using it in a filter, a Spark might do something kind of annoying and push that filter down past something, resulting in bad news bears. And by bad news bears, what I mean is it could result in it having to evaluate the same filter multiple times. And if, for example, your UDF was, say, calling a LLM, this could actually cost real money, not just time, right? And so this is, in my mind, like it's something that we should do, right? I think it makes a fair amount of sense. The argument against this particular PR is, let me try and figure it out. What was the argument? The argument was a little fuzzy. Yeah, the argument was more or less, I think the width approach is not that complicated. Yeah, okay, did they ever do that? I don't think they did. Okay. I tried to push down predicate through width, however, I found there's complex nesting. Legal width cannot generate common expression. It's a bit tricky to make a complex expression only Oof. Yeah. So, right, like essentially the argument here is that there's some better way to do it, but we haven't done that for about a year. And the better way to do it is it's not entirely clear that it works. And actually, by not entirely clear that it works, I mean it's people haven't been able to make it work for a while. So we should probably do the not very clever thing in the interim. Is my argument, but I could be wrong. And this is very much like I'm lazy. We pick some heuristics. So let's go take a look. This was the other one. This is a more complex filter alternative to this one. Yeah, but we can't. This doesn't work, right? So my proposal is that we push down the filter. We're about to duplicate some expressions with. Let's use with to avoid it. At the end of the optimizer, we run the rule rewrite with expressions to rewrite with and pull out all of it. Now this doesn't work. Does it? Did it work? Yeah, it didn't work. So this is the one over here. Yeah. So, okay. Essentially, the argument is there might be a way to do it using with, but it didn't work really. So I don't love that idea. And this filter. Okay. So CloudFan, what did CloudFan want us to do? CloudFan wanted us to always push down. But we don't always. Okay. The thing about this filter pushdown should always be beneficial if we don't duplicate expressions. Yeah, no shit. But the problem is that we do duplicate expressions. The new with expression can avoid expression duplication. Rewrite with expression to rewrite the with rule to pull out common expressions into a project below. Data source pushdown rule doesn't require the scan node to be a direct child of filter, so everything should work as before. I don't. Okay, let's go take a look. Rewrite with expression.scala. Okay. Okay, okay, so now oh, it okay, so it doesn't support aggregate or window functions. If we would we conceivably have a filter on an aggregate that would get pushed down? Uh, we could definitely have a filter on an aggregate. Would it get pushed down? I don't think so. I don't think it would. Well, maybe it would actually. Let's go. The push down logic is something a little gnarly. Yeah, let's go take a look at filter push down suite. Filter push down suite. So okay, yeah, we won't push a filter down through an aggregate, so that's fine. Wait, is that true? Non-deterministic can't push filter down through aggregate with a non-deterministic field. But we would push it down if it through an aggregate if it was a deterministic field. So we would push that down, but okay. So would we need to do that? No, because the thing that we need really is width, and we need width for a greater than 5, and so that's fine. Okay. Okay. So the proposal, let's go look at this, the other change over here from our other esteemed colleague. Do not push down predicate if non-sheep expression exceeds reuse limit. That doesn't, those words don't make sense to me, but okay. Yeah, this, okay. Again, this is this is just worse because it doesn't actually do the width thing. So if we want to try the width thing, we're gonna have to write that code. Fresh. I remember exploring it. I even think I might have a branch. Let's take a look at our branches. 4762, 47672. Okay, let's take a look. This is the split projection one. Is this the... Okay, so is that the... oh yeah, okay. This is the simple one. So I guess instead what we would do is we would just go over here and we would do this. Okay, well, let's the other option. Let's experiment with this. Git checkout master. Oh yeah, sorry. add a note about yj hash map. Cool. Oh, I just remembered I probably need to update. There's like a since, right? Yeah, version. The new config options. Cool. Cool. Okay. Then let's go over here. So, avoid double eval from filter pushdown via width. Okay. So, cloud fan suggestion. Okay, the new with expression can avoid expression duplication. I'm a little fuzzy on the with expression, personally. Let's go take a look on the with expression in a little bit more detail. Okay, an expression holder that keeps a list of common expressions and allow the actual expression to reference these common expressions. These common expressions are guaranteed to be evaluated only once, if it's even if it's referenced more than once. This is similar to CTE, but it's expression level. Okay, that's actually, that makes sense. We do not allow creating a with expression with an aggregate expression that contains a reference to a common expression defined in that scope. Note that it can contain another with okay. So this would work except for the cases where we have aggregates. We can still push through aggregates. We just couldn't create a filter push down where the filter itself referenced an aggregated value. That seems fine, maybe. Okay. Let's go. Let's go find our friend. Let's go find her. And this one is going to just be in the optimizer, and filter pushdown are the two things that we're going to want to change. Optimizer.scala. Okay. Okay. Oh wait, do we do this now? Anyways, wait, maybe this problem's already solved, in which case my life is easier and I don't have to worry about this. Let's go find it. Is it solved or is it open? It is open. Cool. Probably not solved then. Fantastic. Twin predicates. Okay. Maybe this just work. Is that gonna just work? Okay. That's fine. This isn't pushing down yet. Okay. Oh yeah, this is where we start pushing down. Okay. Right. So okay. This is gonna get a little annoying, but we can. Yeah, we can keep hacking on this. Some more. And I've got some fresh coffee. So I think they'll probably have to come back to this in the afternoon. But at the very least, we can kind of explore this filter push down funkiness. Because yeah, it'll be great. Great success. Great success. Okay. Cool beans. Well, thank you all for joining for my spooky adventure. We brought one PR back from the dead, and we sent some messages to look at maybe bringing a second PR back from the dead, but I'm not entirely sure. I think we'll probably actually have to recreate it Dr. Frankenfurter style, I think. It's been a while since I watched Rocky Horror. My apologies. Cool. So, thanks everyone. Have a great rest of your day, and